Yo, what is up everyone? My name is Andrew, and today we'll be tackling the USACO problem, milk measurement. So this is the third problem in the 2017 December contest in the Bronze Division, and without further ado, let's just hop right into it. Alright, so if you would start reading the problem, basically the main thing that you need to realize is that Farmer John has 3 cows, Bessie, Elsie, and Mildred, and the problem is based around the rates of their production of milk, measured in gallons. So they initially have a production rate of 7 gallons of milk per day, and this can change over time. So each time this changes, Farmer John takes a measurement in a logbook. So a log entry would look like this, or the first number is going to be the day on which the change occurs. The second entry is going to be the cow's name, and finally the value, the value in which the output changes. So in this case, on day 35, Bessie's milk output was 2 gallons lower than it was last measured. Pretty self-explanatory there. So the next main point is that Farmer John only has enough time to make at most one measurement on any given day, meaning that this number cannot repeat at any point in time. So unfortunately, he's a bit disorganized and doesn't necessarily write down his measurements in chronological order. So that's another main point, is that these numbers are not in order. So we might have to sort or do whatever later on to accommodate that. So to keep his cows motivated, Farmer John probably displays on the wall of his barn the picture of whichever cow currently has the highest milk output. So if several cows tie, he displays all of their pictures. So please determine the number of days on which Farmer John would have needed to change this display. So we actually don't need to calculate which cow has the highest in the end. We just need to figure out how many times Farmer John needs to just change the display. So this can happen even if several cows tie. So let's just take a look at the input format here. So the first line contains n, the number of measurements, so in this case just the amount of log entries, and then each of the next n lines contains one measurement in the format above. So as you can see here, pretty self-explanatory. And then output, please output the number of days on which Farmer John needs to adjust his motivational display. Okay, so seems pretty simple enough. Let's just map this first one out here real quick. So we have 7. So let's just say this is Bessie, this is Elsie, and this is Mildred. And they each start out with a rate of 7, and we can use this to just say changes. So let's just represent it with CH. So right now the change is 0 because no one's on the top since they're all tied. Alright, so let's just start mapping this out chronologically. So the earliest entry we have would be 1, so in this case Bessie gets an increase of 2. So if we just try running that out, it would be 977, since 7 plus 2 is 9. So that means Bessie becomes the new leader immediately, so that means we have an added change. So Farmer John is going to change the leader of nobody to Bessie, so that's one change for us. 0 plus 1 is 1. Next, the smallest number is 4. And then Elsie, she gets a decrease of 1 in her output, so that means 967. So although that's a change, the leader doesn't change. Bessie still leads with 9, so that means it's still 1. And then the next smallest number is 7, so Mildred gets an increase of 3 in her output, so we get 9, 6, and 7. And Bessie is dethroned as the leader, and now we have another change since Farmer John needs to change the leader display from Bessie to Mildred. And our last entry of 9, Mildred gets subtracted 1, and then she loses the lead, and she gets tied with Bessie. Oops, that's a 9. So in this case, 9, 9. If we get a tie, the problem says to display all the pictures. So that means Farmer John still needs to change it. So that's final change of 3. So if you don't know why we add 1 here, even though they get tied, basically, if Farmer John is going to put Bessie's picture onto the leaderboard, like said here, that's still considered a change. So we still need to add 1 to our amount of changes, getting 3. And as you can see here, that's what they got too. So now that we have a basic understanding of the problem, we can start thinking about our thought process and how we're going to start coding this. Alright, so my initial impression for this problem was that I needed a way to order these log entries, because If we don't order them, that means that we don't know when these changes occur. They can occur pretty much in any order, and that would pretty much mess up when we are supposed to know when Farmer John needs to change the motivational display. So in that case, I created two arrays. And both of them are length 100, as he takes periodic measurements over the next 100 days. So there's going to be at least 100 log entries. But so we don't actually know that. We just have numbers ranging from 0 to 100 or 1 to 100. So in this case, we create two arrays. So I'm just going to draw one here, and I'm not going to draw all 100 slots. Oh, that's kind of ugly right there. I'm not going to draw all 100 slots, but you can assume that this goes all the way to 100 slots. So in this case, based on index, this would be 898, and this would be 99. But we're just going to map out the sample input using my logic here, and the second array over here. Alright. So if we just map this out real quick, for this one, this array is going to store the cow IDs, and each of these indexes is going to represent a day. So if I just section this out real quick, okay, and do this, trying to make it look the same. So these ones store the cow IDs, and these ones store the milk updates or the output changes. Oh, that looks really ugly. And this one stores updates. Alright, so basically both of the indexes for these two arrays represent days. So for example, on the first day it would be index 0. So we have to remember to subtract 1 when we're counting this. So let's say this is 0, 1, 2, 3. So this is the index 4, 5, 6, 7, 8. Oh my god. 7 and 8. And then, okay, looking good. Alright, so this is going to store cow IDs. So basically, let's just say we go in chronological order here. So Bessie. So let's just say that cow IDs are Bessie's 1, Elsie is 2, and Mildred is 3. So these are the cow IDs here. So this is how we're going to identify which cow underwent the change in their output. And that's exactly what we're going to put in this array here. Alright, so first day, Bessie gets an increase of 2 in her output. So in this case, that's a change for Bessie, so we put 1 in the slot that represents the first day. And then in that corresponding spot in the updates, in the first day, Bessie underwent a change of positive 2. So we put positive 2 here. And there isn't any change in day 2 all the way to day 3, so we can just assume that these are 0 or null values in our array. And then we go to 4, Elsie. Elsie is index or cow ID 2, so we put a 2 here. And she has a subtraction of 1 in her output, so we say -1 here. So as you can see, we have some sort of pattern within this array. Next would just be 7. Oh, so it would be this one, index 6. And next we have Mildred with index. So Mildred is index 3, so we put 3 here. This is 0, and she undergoes an increase of 3 in her output. All right, and then finally, for Mildred again, in day 9, so index 8, so this is 0. She undergoes a decrease of 1. So we put that there, and we put Mildred here as well. Alright, so based off these values, based off the values in our array, we can sort of deduce what we did before. So they all start at 9. Oops, let's not put that there. This is 3. So basically they all start at 9. And then based on our values, we can sort of change the values in our code later on. So basically we can see that Bestie goes under a change of 2, and it's basically the same pattern that we repeated earlier. But they don't all start at 9, sorry, they start at 7. Yep, okay. And Bestie gets 9, and 9.77, and then we skip all these null values until we get -1. So then it's 9, 6, and 7, and we skip again, and then we get 9, 6, and 10, and then we get 9, 6, and 9. Alright, so based off these values, every time we have basically a non-zero number in our array here, we can check whether there's a change in leader or motivational display for each time. So in this case, yep, we do get a change. In this case, we do get changes for the cow outputs. However, Bestie is still leader, so we don't get a change here. In this case, we do. In this case, we do. And 3 check marks, it would be 3. And that's how we get our answer. So now that we have our basic thought process and how we're going to write our code here using 2 arrays, we can start coding. Okay everyone, let's hop up to our IDE. So I've booted up this little Java class here called measurements, and I have my input and output methods over here. Alright, so let's just start visualizing what we talked about in our workspace. So let's just read in the input first. So if you go back here, you can see that we get n, integer n here, and then we get our log entries. So we're going to store our log entries into our arrays, remember? So our 2 arrays here, right here. So let's go back. So first we have to read in the integer n, most important. So, and this is going to allow us to loop through the data or the sample input and put it into our arrays. So integer.parse int br.readline. So this is going to parse the string that we read into an integer and store it into this variable n. And then we're going to say, let's just create our 2 arrays of length 100 here. So in cow IDs equals to uint 100. And then our, let's just call it updates equals new int 100. Alright, so then we have to store them in. So let's just remind ourselves what goes into each array. So this one, the ID is going to be the day, but since indexes for array start at 0, we always have to subtract 1. And within those indexes, we put our cow IDs. And remember, Bestie is 1, LC is 2, and Mildred is 3. So Bestie 1, let's make that more clear over here. LC is 2, and Mildred is 3. So let's just int I equals 0, I is less than n. Oops. Oh, I can't type today. Oh god. I plus plus. Let me say string tokenizer st equals new string tokenizer. So this is going to allow us to read in the entries separated by spaces. Let me say, let's just make temporary variables for the input. So in day is going to be integer dot parse int st dot next token, and let's say in ID is going to be equal to 0. So this is just going to be a placeholder for the cow ID here. And then finally, we have to read in, or not finally, but secondly, we have to read in the name of the cow. So let's just say name equals st dot next token. Hold on, let's move the mic here. Okay, that's much better. So there we go. And then let's see here. Oh yeah. So then now we have to. So let's go back here. So based on the name, whether it's Bessie, Elsie, or Mildred, we can change the variable ID to either 1, 2, and 3. So this is just going to allow us to identify which cow underwent the change. So Bessie. Then ID is going to be equal to 1, and we can just copy and paste this. There we go. So else. Let me do that again. Oops. Let me change this to Mildred. and this one to LC. Alright, so and then so LC we get ID is going to equal to 2, and then for Mildred ID is going to equal to 3. Alright, so cool. And of course we have to set the values for the first array. So cow, let's just say IDs is day minus 1. Oh, no, cow IDs day minus 1 is going to be equal to ID. Okay, and then let's just move this here. Then int delta, let's just say so delta is going to be the change in milk value. So delta in math is just going to be the change of total change, value of change. So let's just call it delta for this the last variable here, or just the change, integer change in milk output. Okay, so then, and then finally we put delta into the array, into this array. Let's just call it, yeah, we call it updates. So let's just say updates day minus 1, like the first one, is going to be equal to delta. Alright, so now that we have our input read into our two arrays, each of length 100, let's just map it out again. So like over here, this is where we're going to compare all the values of milk output for all the cows and go through the array and change them and see whether we need to update our leader or display motivational display each time. Alright, so let's just create variables to map out the milk output values first. So let's just say int b for Bessie is going to be equal to 7. E for Elsie is going to be equal to 7, and M for Mildred is going to be equal to 7. So their values all start at 7, like said in the problem, and this is going to be the variable that we're going to return or print out. And this is going to be our final answer. So changes is going to be equal to 0, and we're trying to find the maximum and put it onto the display, or the maximums, and then that's going to be equal to 7 for now. And then we also have to know when to who to update. So let's just write over here. So let's just say that near the end here, so we get 9, 6, and 10 for the values, and then finally we get 9, 6, and 9. So we can actually we can't actually know really when there's going to be more than one cow on the display, since like I said in the problem, let's see here. If several cows tie for the highest milk output, he displays all of their pictures. So it would be too much of a hassle to basically check every time, hey, is there more than one cow on the display? So my method would just be to independently you have variables to check whether, hey, is each cow on the display, or are they about to be on the display? So if the cow is already on the display, then, and there's another one as well, then we can update the change. So let's just say booleans here, b on is equal to true, and e on is equal to true. No, we have to use commas here, and m on is equal to. So this is going to be the boolean that stores whether the cow is already on the display or not, and then this is going to say whether the cow is boolean, let's just say b on next, and so this is going to be the boolean value that stores whether the cow is about to be on it. E on next, and this we're going to compare this with b on, e on, m on, so that we know whether the cow is or the display is going to change. Alright, so let's just go through the array now. So int I equals 0, I less than 100, I plus plus. Alright, so like we discussed here, if the value is 0, then we simply skip over it since there's no change that occurred on that day. So we just need to check whether the values are non-zero or not. So, if statement here. So if cow ID I is not equal to 0. So there's 3 cases here. So cow IDs is either 1, 2, or 3. So if cow IDs I is equal to 1, that means it's Bessie. So Bessie undergoes a positive change on the milk I. So we just assume it's we're just going to add it because adding a negative number is the same as subtracting it. Oh, not milk. Updates. And then we can just copy and paste this again. So else, boom, else, boom, and then this is going to be equal to 1. This is equal to 2, and then it's going to be E and M. All right, so now we've gone through the first array here and basically updated values over here. So now we need to check the display and check whether, hey, are there going to be multiple cows, and how many changes do we need? So let's just say, and max is going to be equal to math dot. So in the problem it says that Farmer John displays on the wall the picture of whichever cow currently has the highest milk output. So we need to take the maximum value out of all of these cows each time. So how do we take the maximum of 3 values? Well, we can take the max of 2 first and then take that value and compare it with the last one. So it's going to be math dot max B, math dot max E and M. Alright, so now we have to use do something with our boolean. So B on next is going to be B equals to max. Alright, so if Bessie has the highest output, then she's going to be on the display next. And if if Elsie has the highest milk output, current milk output, then she is going to be next. So this is just a shortened version of if statement, and I just prefer this over writing out each if statement, copy and pasting. Let's see here, space there. Alright, so now we have our booleans here. So basically, if let's just translate this real quick. So basically, if Bessie is has the current high milk output currently, then she's going to be on the display next. If Elsie is, she's going to be on display next, and so on for Mildred as well. So how do we know whether we need to change the display or not? Well, we change the display if any of these booleans isn't consistent with what we have already. So in this case, so what we have already is going to be represented by, what we have already is on the display is already going to be represented by these booleans. So if B is on, E on, and M on are all set default to true, but they're not actually true, or like in a sense, because all these cows are not on the motivational display, because all of them have equal values. So every time we need to change the display is going to be when a cow is already or not already on the display and we need to change it. So we just need to check for any inconsistencies between corresponding variables of B on next and B on. So if B on next is not equal to B on, or that means Bessie is newly added onto the display, and then we have to repeat this for both Elsie and Mildred. And M on next is not equal to M on. Then that means we have to update the changes, because if any of these cows isn't on display beforehand and is about to be, that means Farmer John used to go change the display. And finally, we update these the boolean values. So B on is B on next, E on equals E on next, because someone that's on next is about to be on. And then we'll also have the new wave of B on next, E on next, and M on next in the next iteration of the loop. Alright, cool. So finally, after writing all this code, what is our main goal? We need to print out the number of changes that Farmer needs to do to display. Finally, we close our two methods for reading in the input and printing out the output. And finally, we can test our data, or test our code. So, you could locally check. Oops, gotta add your semicolons. So you could locally check if your code works using your local files here in the IML. Or I already know that this code works, so I'm just going to plug it in directly to the online grading server. So let's do this. So I'm just going to find my file real quick. There we go. Okay. There we go. Oops, gotta log in here. Do that. And then milk measurement. Let's do that. And boom. Alright, so let's just see if our code works. If it doesn't, we can always debug. But I'm pretty sure that it should work. Alright guys, so I found my error, so it's okay. So apparently, yeah, I accidentally used br.readline instead of string tokenizers, since I forgot it was on the same line. So yeah, I just kind of had a brain fart, but now it should work. So I just tested it locally to make sure. Okay, so measurement out, and now it should work. So go back, and then I have our file here. Alright, so now we can, I'm pretty sure it should work. Yep. And there you go. So thank you guys for watching. I hope you enjoyed. So if you enjoyed, please press that like button and subscribe. My videos will get better over time. So yeah, thank you guys for watching. I'll see you in the next video.